The future of network engineer careers, the role of AI. The world of technology is evolving faster than ever, and with these advancements comes a new era for network engineers, a profession at the core of our connected lives. But what does the future hold for network engineers? And how is artificial intelligence, AI, shaping their careers? In today's video, we'll explore the transformative role AI is playing in the field of network engineering, discussing its impacts, the new skills required, and the exciting opportunities awaiting those ready to adapt. Let's dive right in. Artificial intelligence has gradually transitioned from being a futuristic concept to a present-day necessity. In the world of network engineering, AI has become a game changer, powering smarter, faster, and more secure networks. One of the most significant ways AI is contributing to modern networks is automation. Tasks that once required hours of manual configurations are now streamlined by AI-powered tools. Imagine a scenario where you no longer spend time manually diagnosing network performance issues or troubleshooting errors. Instead, AI tools predict potential problems and resolve them automatically, saving valuable time and resources. AI also plays a critical role in optimizing network performance. By analyzing data in real time, these systems adjust and improve network efficiency, ensuring uninterrupted performance. Furthermore, AI strengthens network security. With increasingly sophisticated cyber threats, AI algorithms can detect and neutralize risks faster than any human could. For modern organizations, this has become invaluable. Ultimately, AI is not just a tool, it's becoming a full-fledged collaborator in the world of network engineering. The integration of AI into networks means significant shifts in the day-to-day roles of network engineers. Traditional responsibilities, such as manual troubleshooting, repetitively configuring networks, and conducting routine maintenance, are becoming relics of the past. So, where does this leave network engineers? As AI handles these streamlined operations, engineers must transition to higher-level tasks. This includes overseeing AI systems themselves, orchestrating complex network strategies, and focusing on long-term improvements instead of short-term fixes. If we compare this shift, it's as though engineers have gone from being mechanics to architects, guiding structural innovations in how networks are built and managed. This evolution allows engineers to step into more impactful roles. Instead of scripting minor fixes or debugging isolated incidents, they are now empowered to deploy creative strategies that can scale across industries and processes. While automated processes may reduce the routine workload, they increase the demand for engineers capable of strategizing in this new AI-powered landscape. In this new chapter of network engineering, staying relevant means staying adaptable. So, what skills do network engineers need to thrive in the era of AI? The first and most obvious is understanding AI-powered tools. Engineers don't need to become AI researchers, but they must know how AI algorithms function and how to apply them effectively in network systems. Next, programming skills are becoming non-negotiable. Languages like Python and scripting tools are highly valuable in environments where engineers now integrate AI-driven apps or refine their functions. Machine learning expertise is also key. Engineers don't need to master all nuances of neural networks, but basic knowledge in supervised and unsupervised learning models will allow them to leverage AI for better results. Additionally, data management skills are vital. AI thrives on data. By managing and analyzing large sets of network data, engineers enable AI systems to make informed decisions. Human skills are equally essential. Creative problem-solving coupled with adaptability will define future-proof professionals. AI systems excel in generating solutions, but the ingenuity to figure out when and how to use those solutions comes from human insight. While the future seems bright, every transition brings challenges. For network engineers embracing AI, one immediate obstacle is the learning curve. Upskilling isn't optional, it's mandatory. For those who have spent years mastering traditional methodologies, adapting to new AI-centric tools could initially feel overwhelming. Another challenge lies in the technology adoption gap. Not all enterprises have the resources to immediately integrate AI systems into their networks. Smaller businesses might struggle to keep up with the pace of digital transformation, potentially limiting engineers' access to the latest tools. Lastly, there's the concern of job security. With AI assuming more responsibilities, it can seem that engineers are being replaced. However, that couldn't be further from the truth. This concern often stems from misunderstanding. AI is a force multiplier, not a replacement. It enhances what engineers can accomplish rather than eliminating their purpose. Facing these challenges with a growth mindset and a readiness to embrace change will prove essential for professionals going forward. Where challenges exist, so too do opportunities. AI's transformative power is opening doors to exciting possibilities for network engineers. First, there will be a massive increase in industry demand. As the reliance on digital infrastructure grows, companies will need professionals with AI-integrated expertise to design, operate, and secure networks. Moreover, AI expands the horizons of networking beyond traditional sectors. Engineers now have opportunities in industries like healthcare, where AI-driven networks enable life-saving technologies such as remote surgeries and patient data management. The finance industry is another key application area, powering secure real-time transactions. Additionally, telecommunications rely heavily on AI to improve service delivery. AI also paves the way for network innovation. Developments such as self-healing networks, systems capable of detecting and patching vulnerabilities automatically, are on the rise, thanks to AI integration. These advances highlight the exciting, future-shaping roles network engineers can occupy in creating smarter, safer, and faster connections. Lastly, as AI becomes central to the foundation of global industries, network engineers can step into leadership roles, helping organizations strategically align their operations with AI's capabilities. To make the most of these opportunities, engineers must take proactive steps to prepare for this transformative era. So, how can they start? One key action is upskilling. Engineers can focus on learning programming languages like Python, delving into AI, and studying machine learning basics. Many online resources and training platforms provide accessible options for building these skills. Enrolling in certification programs is another effective route. Industry-recognized AI and network engineering certifications not only expand knowledge, but enhance employability in competitive markets. To supplement formal education, gaining hands-on experience is invaluable. Working on AI-related projects, participating in open-source communities, or collaborating with peers can deepen practical insights into applying AI in real-world environments. By taking the initiative to learn, experiment, and adapt, engineers will ensure they remain at the cutting edge of this ever-changing field. While AI is a powerful tool, it's important to understand it as part of a collaboration, not a replacement. The future of networking lies in a partnership between humans and machines. AI excels at handling vast amounts of data, identifying trends, and executing automated solutions. But it lacks creativity and intuition, qualities that human engineers bring to the table. A great example of this collaboration might involve engineers adapting AI algorithms to tackle unexpected issues or interpreting AI-generated insights to improve the design of a network. This synergy is already proving invaluable in areas such as predictive analytics. Engineers use AI to predict future network failures, but the decision on when and how to address those predictions still requires human judgment and input. The message here is clear. AI will never fully replace the need for skilled, insightful humans. It's a tool for amplifying their abilities, not a substitute for their expertise. Looking ahead, The role of AI in network engineering is only set to grow, bringing not just transformations to the field, but also fascinating possibilities. Over the next decade, we can expect AI-powered systems to embed themselves further across all aspects of networking. As these networks grow more intelligent, the responsibilities of engineers will also dramatically evolve, involving not only technical work, but also leadership in global technological advancements. This could involve spearheading ethical AI practices, ensuring the responsible development and deployment of machine-powered systems to avoid misuse or oversight. By embracing AI today, network engineers are not only preparing for their personal professional futures, but are also shaping the next wave of innovative technologies that will impact generations to come. The future of network engineer careers is undeniably intertwined with artificial intelligence. But far from being a threat, AI is an opportunity, a force enabling smarter, faster, and safer networks. By adopting AI tools, adapting to new roles, and building the right skills, network engineers can secure their place in a future defined by innovation. So, whether you're a seasoned professional thinking about your next step, an aspiring IT enthusiast eager to enter the field, or a business leader looking to empower your team, the time to understand AI and its transformative potential is now. Remember, the future doesn't wait. Will you step forward and seize it? Thank you for tuning in. Let's create the networks of tomorrow together.